Hello, Professor, and all other viewers. Today we are going to present our project Unibank Marketing Campaign Demo done as part of CMPE239 course at San Jose State University in spring 2016. Who are we? We are Team Unicorns, and our team members who contributed and developed this project are Sweta Boba, myself Kovidev Reddy Nala, Anusha Konatala, and Raviteja Kanteti. So, here comes our problem statement. One of the bank called Unibank has approached us to convert their new telemarketing campaign for introducing in their fixed term deposit scheme to customers, and the goal for them is to have maximum conversions out of this new telemarketing campaign which they are hosting soon. So our team has come up with a solution in predicting the decision of the customer whether he or she would be interested in such a service. Like for here is a fixed term deposit service. Yes. So what we are doing, we are training the existing data set given to us by the bank, and we are using here the UCI machine learning bank marketing dataset, and we are applying the trained model to predict the customer decision. Once we predict the customer decision, the bank agent who would log into our application would enter all the customer details and check if the customer would be really interested in taking the new fixed term deposits. So once he checks if the customer is interested, he goes and calls the customer and tells about the new fixed term deposit scheme, and he would get a result back, hoping a positive result based on prediction results. And for all the customers for which our model predicts a no, the bank agent wouldn't call them, saving time, resources. And finally, the bank agents call only to customers who are actually willing to enroll into the scheme, so that to get maximum conversions out of this telemarketing campaign. So what we are using the dataset, bank marketing dataset, which is actually is the most identical to any of the dataset which looks like here. So these campaigns are based on the phone calls made to the client. All the data shown here is like recent phone calls and the conversation data which is made with the client. There are like 41,188 instances in this, in which total of 16 attributes are used. So what I would do is, like, I would go and show you the data set with the data set we are using. So here you see our data set, like there are different columns. This is the original data set with like 41,000 rows. If I go down, it's like, so it has like 41,189 rows over here. So, and the first row is the header row, so it's a total of 41,188 records. So what we have different columns here, like age, job, marital status, the education, housing, loan, contact. But do we need we can actually train the model with all these columns, but what we are doing here is, like, we are refining to set of featured columns, because all these columns would not be influencing columns for the outcome label. And we have the outcome label with column Y, and the last column which shows here is like no, 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 and there's mostly no's here, and there'll be little s. So this one would be our class label. And we could explain like few of the column variables, like, when we say the previous here means the number of contacts performed before this campaign and for this client. And the P outcome, what it means is like outcome of the previous marketing campaign, either it is like a failure or non-existent or the success. And here, if you can see, like, the Euribor rates over here, the Euribor rates, the column is here, the Euribor rates. So if you see, the rates are here, the Euribor rates is nothing but a 3-month Euribor rate, which is actually a daily indicator. And there are, like, these are the multiple columns in which we are using the data set. So coming back to our presentation, so this gives a screenshot of our data set. So now, once we have the data set with us, what we are doing, so we are actually following the KDD process. So first we do select and understand the data set. Then we are removing noise, outliers, and missing values. So we are doing a pre-processing step for the data set. How we are doing it, I will show you in a while how we are doing it. We are doing it through the Python, Panda, and NumPy packages, using them to do the cleaning process, data cleaning and exploration. And then we select the featured columns and reduce the data set, and that data set will be sent to the data mining algorithms we actually trained our models in Python through Python scikit packages for different algorithms, machine learning algorithms, which we are going to discuss in a while. And we were also using Azure Machine Learning Studio for the same thing. And we will tell you like in a while like why we choose both of them. And then finally we analyze the results and give a predictive model to the end user. So what I would next I would do like so what we are doing, we have done the data exploration through Python. We are cleaning data, we are identifying potential features in dataset, replacing null values, removing outliers, and replacing unknown values with the most occurring values, and how data is behaving. And transform, these are the few things which we are doing, like transforming row data in column level. So these are a few things which we are doing. I would like to show the real code here, which we're doing in Python. So if we go to the Python shell over here, if I type localhost, so what I'm opening is like I'm opening my Python notebook where my scripts are written for a dataset. So if I click on explore data demo, it opens up here. So what we are doing, so here we are actually importing the Python package like the pandas and numpy, and these are the import statements. And so we are taking our data set, we are reading the data set, and if you can read the top 5 rows, it gives the initial data set. So then next what we are doing is like we're checking out how many distinct values of s and no are there here in the data set. So and we are mapping the outcome with no to 0 and s to 1. We are converting the text values into numeric values, which actually uses us in aggregating results, aggregations, and statistical, which will be useful for statistical analysis. So this is so what we are doing is like we are actually, one of the thing is like if we explore the data, we are trying to explore the data for with each column versus the class label for the versus the outcome. So if you see here, for the age 98, we see there's a 1, there's like people with age 98, they have like 100% accepting for the new scheme. But we would like to see how many customers actually accepted with age 98. So if you see here with bank read age 98, there's only like out of the 41,000 rows, there's only 2 people with age 98. So this would not be a great, first it would look to us like it's a like great feature, but now it doesn't look like a great feature for us. So next, we're actually plotting with age and outcome. So just to see like if age is a factor for taking the new scheme, and we see this looks like a useful feature. So here we see the quartile ranges through the box and whisker plots plotted over here, and looks like both the medians over here for no and s has at the same range. So we think this may not be a deciding column for analysis. So in the same way we are doing it across each columns. Okay, and next what we are doing is like there are different categorical values, like here there's a categorical values for job like admin, blue collar, entrepreneur. So what we are doing is like here we are creating dummy variables. So why we are creating dummy variables is to convert categorical variable into numerical variables. So we are calling this an indicator variable. So it will this when converting categorical variable to numerical variables, it would act as a predictor in all our statistical models. So so that's why we'll be creating all the dummy variables for all these jobs. And also for the p outcomes, we create a new dummy variables like p outcome failure, p outcome non-existent. Okay, so this is how we do. I'm just going through it quickly. So this is all the code written to for data exploration and all. So if we go down. So let's discuss one of the great features here, Euribor rates. Let's see how Euribor rates. So here we see the Euribor rates, and we plot a box plot for Euribor rates, and we see both the medians for no and s vary by it's the for the no, it's the median is nearer to the quartile 3, whereas here the median exists between the quartile 2 and quartile 3. So, and there's a difference. So from the above we could see that the lower the Euribor rate results in more deposit, and higher Euribor rates has mostly in the negative side. So based on the I think the Euribor, we think Euribor rates is a great feature, so we included Euribor rates. So finally we have decided the influence columns like the default. These are the 5 columns: default, contact type, previous, Euribor, and we have added all the columns here, denormalized dummy variable columns we created, which actually are part of P outcome and the job column, which are categorical variables which are converted into numerical variables needed for statistical analysis. So once we have this, so if you see here we have this, we can run in a Python shell. We ran, so we'll see number of values of s and value counts for s and no. So these are the outcome types. We can see like there are like 36,000 no's and 4,640 s in our data set. So now what we do is like we would show you like how we could create a logistic regression model here for our classification. So I will be running this. So I would like to show you how it runs. So I'll go click here. So here we could see is like 89%, 89.86% accuracy. That's the score. It's like it could predict 89.86% of accuracy. So let's see what's the outcome value dot mean. Let's see the outcome value dot mean. Okay, so what it says, out of in our data set only 11.2% people accept for S, whereas 89.86% say no. So we can say that 11% accepted the new marketing service. That means we could obtain 89.86 accuracy by always predicting a no. So next we can examine the coefficients. I'm running it now. So this is a featured weight classification across all the data labels, all the influence columns. Then what we do is like now we would actually train our data. We could actually split our train and test data set over here. So then we write our model as logistic regression and we fit the train data actually. So here we are doing the training process. So these are the weight logistic regression parameters for training. Then we can actually predict the class labels, and we can also print the probabilities here. We would like to show you the same. So print predictor 0 means the is like a decision no, and we see the probabilities of this. So these are the class probabilities, and on the second column in each row it shows that the probability of happening. So if you say here the first row, there is 3.9% probability for it to say S. So and we can also say, if you were running this, so what we can see here, we can see here there's an 89.79% accuracy score or on this. It's the same as we experienced when training and predicting on the same data. Now we are testing with other test data which we are importing. So is the same. So we can also see the confusion matrix here. Like here, if we show you the confusion matrix, I would like to print the confusion matrix here. So this is a confusion matrix. So what's a confusion matrix? Confusion matrix is nothing but it shows the number of correct and incorrect predictions made by the classification model compared to the actual outcomes. So next, once now we are done with training and testing the model, we have got 89.86% accuracy. That's great. Initially, when we did with the normal all regular columns, we got 81% accuracy. Now with the featured columns, we are only taking the featured columns here. If I go up and see, these are the featured columns, influencing columns. With this influencing columns, we get only 89% accuracy, which is a hike of 8% accuracy increase. Then next, what we do once we got the accuracy and all, so we would like to predict the model. So what we are doing here, here we are predicting the probability by entering the values for these columns and trying to see if the customer, these are the customer details, and this is the Euribor rates, and one indicates an S, like one indicates the previous outcome is a success means once, fail means no. Oh, these are the labels. So if I run, when I run this, so what we got here, so here we got this value is, there's a 40% probability that this customer, based on the data given above, is will accept the new term deposit scheme. So likewise we have written, now you have seen like real execution of the code in the Python shell. This is a Python notebook shell, to mention. So here we have written for SVM. In the same way we have trained and test model, and we are predicting here, and we have written for random forest. So this is all we are doing here through Python. Okay, so now let's go back to our presentation. So this is our data flow to explain. So we understand the business requirements, we understand data, we have prepared the data, we evaluate data, and train the model. Once we train the model, we deploy the model and we use it in our service. So here we have seen the data cleansing and exploring. So we have explained you in the Python shell about the featured columns we got. These are the featured columns: default, contact, previous. And then we have trained models and testing models using, we have trained through Python packages. And we actually thought of connecting the Python package to the user interface, but we thought like Azure Machine Learning Studio is a great choice for us to integrate for our front end with the back end. So Azure Machine Learning Studio is same, I like the Python package which we did, but it has a greater features, greater learning models, so we choose this, and it's a cloud computing platform, and it can use a machine learning component of the platform to analyze the trained data. It has the feasibility to create complex machine learning experiments. So and the data, like the Python package, it's used trained and the model is coded and evaluated. So why Azure? It's like reliability, and it's like even the server crashes, the application still running on other servers. It's scalable, and it's like huge machine learning stack which has, we are taking benefit of that. It supports different programming languages and tools and frameworks, which makes our projects and helps, and also makes up easy upgrades too. So this is how modeling data in ML Studio. I would like you to take you to the ML Studio actually. So this is our ML Studio. We could go to ML Studio here. So ML Studio actually gives deployed web services of the model. So we could actually use it in our, we are developing the main stack application, so we could actually directly use these web services there. So if I go and open this Python neural network training experiment, so if I zoom this thing, so what we have now here, we have a Python data, which is actually, if you go and visualize, so it's a new columns, it's a clean data set with only the columns which are only the influencing columns. Then we split the data for training and testing. Then we apply the algorithm here. Let me zoom in. We apply the two class neural network algorithm to the data. We train the model and we score the model and we evaluate the model. When we evaluate the model, we could see the evaluation results here. You click on visualize. So here you see the evaluation results. Is this a you can see the score model, and here you can see the confusion matrix, and here you see the accuracy of 89.6%, the precisions and all. So you could see an ROC chart here. What's ROC chart is similar to gain or lift charts, but they provide a means of comparison between the classification models. And this is a precision or recall chart, and this is a lift chart. So this is the evaluation model. So here when you click on the train model, if you click on the two, okay, next we click on the train model here. So you could see the properties of this, properties of the evaluate model and all. I would like to see the two class properties. Here, see if I'm trying to get this thing. Okay, when you click on the two class neural network, here you can actually create the trainer mode, give the parameter range. Here you can hidden layer classification. You can have the number of learning iterations. Here we have put the learning iterations to 100, and you can actually choose multiple options here. This is one of the flexibility we can get in Azure Machine Learning Studio. Once we have this thing Machine Learning Studio, we can get the predictive experiment. Then we click on the deploy web service. When we click the deploy web service, it will give us an URL where we can deploy and test the web service. This is actually used for predicting model. So it's actually deploying the web service now, and then it gives us the API key. And when I click on test, we could actually give the values for the fields here. And when we click on OK, it actually gives us the output. So when I click on request and response, it actually opens up this URL, and this is our post URL, and we have to send the request in this format. We'll fill the values. Here it's 0 by default, but we fill the relevant values for the column names here, and we get the response in this format. And we get the response of scored probability and the scored label. Based on the score probability, we will decide which class it belongs to, whether it belongs to S class or whether it belongs to no class, whether the user will accept the new term deposit or not. So coming back to this thing, this we have learned. So here we have considering these are the class for the classification algorithm. For our problem statement, we are considering in these algorithms mentioned here, like the logistic regression, neural network, decision tree, decision forest. Why logistic regression? Logistic regression is used for measuring between categorical dependent variables and independent variables, and it performs well with few categories and few categorical variables. So we are using logistic regression. And neural network are relatively crude electronic networks of neurons based on the neural structure of the brain. So we choose the neural networks to process records one at a time and learning by comparing the classification of the records. And we are choosing decision tree is like normal decision tree as a predictive model which maps observations about an item to conclusions. And decision forest is it's like decision tree. It's an ensemble learning method of classification, and like by constructing they operate by constructing a multitude of decision trees at training time and outputting class, that is mode of classes. And SVM is another class where, like, if there is a two class problem, like for us here, like S or no, with balanced data set and noise free or little. So it has flexible selection of kernels for non-linear correlation. So these are the choices for choosing these algorithms. And I would like to show our application, which is at this URL. When I click this, let me go to this URL. So if I go to this URL, so let me open in Chrome, uniquebank.herokuapp.com. So this is our website. So here we have a campaign. So this is our campaign. They want to increase the things, so we can enter input about the customer here. So here I can enter input like Euribor rates 1.2. I can enter the customer ID. I can give the age. I can education status. I can choose a marital status. I can say job retired. I put the age to like 68 or something. Education status, I put masters. Okay. I can give credit default as. We can put the balance in the bank account 2345. Contact by telephone owner. We can choose the last contacted date. Do they have a personal loan? So we are choosing all the things. Previous items 0, previous items 1. We could choose last contact. Previous outcome success. So once we choose this thing, we click on submit. So what happens is, like, it gives like score probability is like 54% is the probability that the customer will accept us. So if the score probability is above 0.5, we are assigning to the score result class to 1. If the score probability is less than 0.5, we assign it to score result class 0. And here we can enter the customer number. Here we have put a launch application to actually enter the number and call through Skype. So we can enter the number like 48917. I can enter a number here, 489999999, any number. So, and also we have a view comparison if the end user wants to compare his results with other algorithms. So here you could see like classic logic regression, and both of them are giving the 54% and 67% probability. And the neural networks is giving 45%, but the boosted decision tree and decision forest are giving like 37 and 29%. So the bank agent can also look at these probabilities and check like if most of the outputs are 1, or the score label, or if they can put their own custom probability criteria cutoff, like 40% is the probability they can choose, and they can call the customer based on the results for additional purposes. So this is a demo, and we could if we go to home and we can go to algorithms. So these are algorithms used by us, and here it shows the algorithm accuracy, like logistic regression shows 89.8%. So based on the accuracy, we have given the default result for the customer. When we go here to get started and enter input, so here the default score result class and score probabilities for logistic regression, because that is the best method machine learning algorithm for our problem statement. And also if we can go to we can go and see the infographics graphs. These are the different data insights developed from the data, the train model, and you can see the decision trees form. So these are the score labels and probabilities in the final. So these are the total score probabilities, and these are the total score labels, and here you can see the feature based classification. So we can navigate to the home page. So next thing I would like to explain, so here we have another feature called upload import dataset. So what is here? So import dataset is a feature where we could actually import a new CSV file. If you can go to documents, I can go to data bank, I can go bank additional, I can enter some additional CSV. So the data set is imported. So what happens now is like this data set is used as a trained model with existing one, and actually updates the model, and when you click on enter input, it gives an updated model here. So this is all about our prediction model. So let me predict some other value with like Euribor rates, like on other day it can be like 3. I can choose other values like age 22. I can select like bachelor's, single, job is like student. Let me put student. Okay, student is over here. Credit default, no. Telephone, previous attempt 0. Previous outcome failure. Previous outcome you can say other because it's unknown. You click submit. So what it does is like it says like for this category it shows like 14% probability that this user will accept for the term deposit scheme, and the score result class is 0. So and how we are doing this? We are doing this application through Node.js. We could show you the no server.js code. So here we take the neural network code. So this is the server.js code. So here this is the URL here. This is the host name. This is the path after the host name, and the method is post, and here is our API key. So we are forming our request as required. We're forming request in this format, and we're sending values from the user interface to here. And then once we get the result, it goes and hits the Azure Machine Learning Studio and gets back the result, and it shows back in our UI here. You can see the comparison results too here. So these are the results. And if we go back to a PPT, so these are why we use logistical regression, and these are the results as we have already seen the results, and these are the confusion matrices and ROC graphs. So I'm quickly skipping over this. So what's the conclusion? The conclusion is logistic regression is the best performer here among other algorithms like the neural network, decision tree, decision forest, or the support vector machine. Each algorithm has its own good features, but in our scenario and according to our problem statement, logistic algorithm model trained on our data with the feature set of influence columns like we have seen before resulted in more efficiency and accuracy, which is 89.86% here in comparison with other algorithms. So we on overall we could say like logistic regression is the best performance for our scenario. So this helps like introducing useful products and services to interested customers and accomplish relation between the customers and the banks. And our predictive model thus brings huge customer conversion rates in telemarketing campaigns, and it's actually resulting in saving time when saving money to the banks, and also increasing conversions and profits to the telemarketing team. And you can view the application deployed on cloud at the link specified here, uniquebank.heroku.com. And these are the team members who are involved in the development of this project. And last but not the least, we would like to thank for the in-class sessions by Professor Chandrasekhar Uppalapati and all his interactive course sessions and course material which actually helped us in successfully completing our project. Thank you.